Hello everybody, my name is Jim Pingle, and this month we'll be talking about routed IPsec on pfSense in our June 2018 Hangout. First, we're going to talk about Netgate news. We'll talk about what routed IPsec is and why you'd want to use it, some limitations on it, when it's going to be generally available, how you would configure routed IPsec, and then I'll go through a static routing example and then a couple of dynamic routing examples. And I've got another one beyond that too for policy routing that didn't get in that list. All right, first up in our news, our Tensor product is now available on Amazon Web Services, or sorry, AWS. And that is a very high throughput routing platform that you can use to push quite a lot of data between AWS regions if you need to. It's up there. I think there's even a free trial available. Just hit the link and read up about that if you want to give that a try. Since our last hangout, pfSense 243p1 and 235p2 have been released. You can read the blog post about that. Mostly security fixes, and there's some OpenSSL fixes and lots of other little bug fixes and a couple of minor little feature things that snuck in. But not huge things, but still good to keep up to date. If you haven't updated your systems yet, you might want to get those up to date. We are working on our pfSense 244 version. It does have fixes for the latest variants of Meltdown Inspector, plus there's a lazy FP state restore bug that was just discovered. We've got fixes for all that in there, and that's all in snapshots. If you want to, you can follow the link and check out our post there about the recent security issues that have come up. And those are just general processor issues and platform issues, not really specific to pfSense. 244 is going to have a FreeBSD 11.2 base, which FreeBSD 11.2 release just happened a couple days ago. So now that that's out, we can get some good proper basing in on that. It is going to have routed IPsec, which we're talking about today. We're also moving to PHP 7.2. Our installer now is going to have a hybrid memstick and ISO, so that you can download the memstick if you want to use it as an ISO. You just change the name from .img to .iso and burn it, or you can load an ISO in like VMware or whatever your hypervisor of choice is, and it just boots right up. Also, since the last time we had a hangout, we have a new forum up at forum.netgate.com. Mostly was migrated for GDPR compliance. We migrated away from SMF because it wasn't compliant to NodeBB, which was, and it's a much more overall, better browser and mobile experience. It's a really slick package. We're still kind of tweaking some of the look and feel stuff, and even now it's been up for over a month, and we're still finding things to tweak and change here and there. Our documentation wiki that used to be at doc.pfsense.org, that's been converted to Sphinx. It's now at netgate.com/doc/pfsense. There's a blog post about why we moved that as well. But the gist of it is, it's easier to take contributions with GitHub PRs because it's all in GitHub. You can, if you see something that's wrong in the documentation, there's an edit button right there that will let you take you to GitHub. You can log in, make changes, and submit a PR, and we can review it and accept it. We don't have to worry about maintaining a wiki anymore, especially it had its own login database and all that. And again, for GDPR, we're trying to minimize the amount of information we had to keep. So we're also, as a consequence, we're trying to find better ways to do all this stuff. Also now, whereas with wiki editing, we kind of had to police things. We had to watch out for everybody editing things, and we have to go through and review things after they happened and then clean it up, which was not very efficient. We had to be kind of reactionary, but doing things with GitHub PRs, we can take these contributions when they're still in a pull request state, review them, test them, see how they look, and offer commentary to the authors before they're accepted, rather than playing catch up. And so overall it's a better workflow for everybody, and we've already seen several contributions that we've been able to merge in. It's been a very positive move so far. Another product change here, we now have pfSense available to QNAP virtualization station users. If you use QNAP, you can log in there into their little store and activate a pfSense VM straight on your NAS if you need to. Follow that link there, and if you want to read more about that. Also, again, for GDPR, we do have updates to our privacy policy. You can read those on the blog. We were in, also unrelated to all that, we were at Netgate. Netgate was at BSTCan earlier this month. We posted some pictures and things to Twitter if you want to check that out. The bulk of that, all that is, a lot of things were related to GDPR, and that's why we didn't have a hangout last month, is because we were all hands on deck. Everybody was scrambling, trying to get everything in place for GDPR, so we just didn't have the resources to cover it last month. Okay, moving on to the topic at hand here. So what is routed IPsec? Well, route-based IPsec is different from traditional tunnel IPsec or policy-based IPsec. It uses virtual tunnel interfaces, or VTI, which I'll probably just abbreviate that to VTI through here. Support for it has been in FreeBSD since FreeBSD 11.1 with the IPsec interface or IPsec interfaces. And that was all part of a whole IPsec stack cleanup that came in with 11.1. It does work with IKV1 and IKV2, and it creates an IPsec interface at the operating system level. If you've used IPsec on pfSense, you might be familiar. It uses the ENC0 interface. The traffic flows through that. Well, that still happens here, but there's also a separate IPsec interface that has its own addressing, and things will flow through that too. So that IPsec interface, you can assign it. You can use it like other interfaces. It works kind of like an assigned OpenVPN interface at that point. Gets an automatic gateway that's created, so you can use it for policy routing. You can use it for some NAT and routing, static routing, dynamic routing. But it is completely optional. You can still do traditional policy-based IPsec. Nothing wrong with that. This is just an additional option you'll have in your toolkit if you need the flexibility that you get from routed IPsec. And well, speaking of flexibility, why would you want to use it? Well, traffic flows in a more natural, logical way. So if you're used to how traffic flows, in the operating system level, you got routes in your routing table. You put in a static route, that's where traffic's going to go, or you can do policy routing, things are going to go there. With policy-based IPsec, there's all this kernel magic that happens. It just grabs packets that match your security associations, shoves them into IPsec, or it might catch things that come in that match, in what it thinks is the wrong direction and filter them out. Or you won't see your security associations in the routing table either, so it can be kind of confusing. If you're used to seeing that, we get questions all the time about, I have this IPsec tunnel. Why are there no routes in the routing table? Well, with traditional policy-based IPsec, it doesn't route, but now with route-based IPsec, it does. There is kind of a trade-off with phase 2 definitions. You don't have to define phase 2s for every network crossing pfSense anymore with routed IPsec. You just need your routes, and so any traffic you send into or through the IPsec interface is going to cross IPsec. It doesn't have to match any policies, so you have a lot more freedom there, a lot more flexibility with what you do, and so again, that kind of works in your favor too with policy routing things. You could use you could route from one side to an internet connection on the other side and only send select traffic through. So this also, it works with other routed IPsec implementations like our Tensor platform or AWS VPC. I'll talk a little bit more about that later, but it works best when you have routed IPsec on both sides. It can utilize gateways and gateway groups. So again, selectively sending traffic across policy routing certain internet destinations, you can do that now. You can also do failover between multiple tunnels with gateway groups or with dynamic routing. You can do BGP or OSPF dynamic routing between multiple IPsec connections, or even between something that's IPsec and something that's not. You could use it for multiple WANs, AWS VPC failover. That kind of stuff is all in the pipe here. Again, IPsec with large numbers of subnets, since you don't have to list out all of these P2s and just routes, you have a little bit more freedom there. I know adding all those phase 2 definitions can be kind of cumbersome, but with routed IPsec, you can handle it with routing, or you could even handle it with a dynamic routing daemon. It will greatly simplify your management in some ways. So You can also send traffic to and from the firewall itself across IPsec. We've had a lot of issues over the years with people that have needed to send traffic from the firewall itself across IPsec, but the way a lot of these services, especially services that are UDP or similar, the operating system will source the traffic from an address that's closest to the target. And because there was no entry in the routing table for things across IPsec, these things would get sourced from the WAN, which wasn't a part of the IPsec tunnel, and so the traffic would just sort of die because it didn't know where to go. Or it didn't know how to reply back to where it needed to go. But now, because it's going to have a routing table entry, it works just fine. You need to send a radius query from the firewall over IPsec, fine. LDAP, fine. You need forward syslog over IPsec, that works too. Hit SNMP from remote, that's fine too. DHCP relay should work now, and it didn't before. All of those things are a possibility now because it will see these routes and source this traffic from the IPsec interface going to the other side. Now, it's not all sunshine and roses. There are some things you need to be aware of in terms of limitations and downsides. It's only optimal if both sides support routed IPsec. It can work if there are things, if one side is and one side isn't, but you lose a lot of the benefits of routed IPsec. It takes some fussing with your P2s to make sure it doesn't work. So if you've ever tried AWS VPC, the AWS is doing route-based IPsec, pfSense wasn't, so you had to do this weird thing with like the virtual IPs and binding them to the LAN or the local host or the LAN or whatever, and then adding these extra P2s, and it was just sort of weird and confusing. We had a wizard that would help with it for people that were running our factory versions, but it's sort of a moot point now where with routed IPsec it all just lights up and works. We'll probably still keep that wizard around, but we're going to adjust the wizard so it uses our FRR daemon and also so it will do route-based IPsec. Another limitation is the trade-off of, instead of managing phase 2 entries, now you have to manage routes. That could be easier with the dynamic routing daemon. It could be easier, if you're more familiar with routes. But for some people, like to have everything, all together. It's kind of a downside because before they could manage everything in IPsec, but now they have to think about routes. So really, it's kind of a trade-off, but it's something. If you're going into it aware of that, it's not a huge deal. But it comes down to the preference of what your needs are. There is some weirdness with how the traffic shows up at the operating system level on the encryption interface and the IPsec interface. At the moment, like inbound traffic has to be passed on the IPsec tab rules. If it's not, it never gets to the point where it can be considered by the IPsec interface. Outbound traffic is handled on the IPsec interface, for things like NAT, but it's all stuff we're still trying to work out the fine points of the issues there to see if there's anything we can do, or if that's something that FreeBSD needs to fix upstream, and it's looking more like it's a FreeBSD thing they need to fix. So we're still testing all that out. There are some issues with NAT. You can NAT to the interface address just fine. That works okay. Like you can do outbound NAT that NATs traffic leaving IPsec to that IPsec interface address. No problems with that. But if you try to do one-to-one NAT, like to NAT things to a separate subnet or to NAT to a single address that's not your interface address, that's not working right now. But we're trying to see if there's a way we can get that to work. If not, we may have to kick that up to FreeBSD and see if there's something that needs changed in PF or the IPsec processing upstream. Something else to be aware of, people have done this sort of thing with routed IPsec in the past with transport mode and GRE, which was popular, especially in Cisco realm. But this is not that. So if you need to connect to something that uses transport mode and GRE, you'd still have to use transport mode and GRE. So this is not the same. It works in a similar fashion. Actually, this works a lot smoother, less problems here. But again, it's not the same thing. Those do not interoperate. And again, it's a brand new feature, and though a lot of our internal testing has gone very well, it's still very new. So we haven't beaten on it a lot to figure out all of these scenarios and see if they all work. So far, just about everything short of the NAT things I mentioned has worked just fine for us. But there's still a few things we're not 100% sure on, but it's shaping up very nicely to the point where I'd be comfortable using it in light production at the moment, maybe even heavy production. But we're still in a beta release or not really beta, we're in a development release at the moment. So if you want to try a snapshot, you can, but I would do it in a lab first, and then if you're comfortable with how it is, then go up. But still a lot of active development going on with 2.4.4, so I would definitely not put that in production unless you're a very, very brave soul. So when are we looking at this being available? Well, like I said, it's in snapshots right now. It's going to be in 2.4.4 release, and that release should be out here in the next couple of months. It's still a work in progress. All the core functionality is there. There are some things, like I said, that we're still testing. We're still doing a lot of testing, like I said, with NAT and failover and things like that, trying to see if there's any corner cases or edge cases that are weird, and if it's something we can fix or something we just need to document and work around. We're also working on the documentation stuff yet. Now that I've gone through everything for the Hangout here, I'm going to translate that into some documentation. We'll get that up on the website before too long. So that'll all be available soon. Okay, so let's get to the nuts and bolts of this and how you configure it. First things first, you need to pick a transit network. Sort of like if you've done OpenVPN, you need to choose a tunnel network, similar to like a shared key instance or a site-to-site SSL TLS type thing. But it's going to be a /30. You only need 2 addresses, one for the local side, one for the remote. As you can see in this instance, I chose 10.8.222/0 or .0/30. And then like any other IPsec, you need to know your local and remote settings. So my local IPsec endpoint here is 198.51.100.8, and the remote is 203.0.113.5. I'm going to do an IKv2 tunnel, PSK auth with just a really long key there. As you can see, it's really just a bunch of sequential numbers, but I just wanted it to look long and fancy. For phase 1 encryption and hash and lifetime and DH, it's just AES-256, SHA-256, DH14, 28.8, 100. For my local P2 endpoint is 10.8.222.1/30, which is the first address in my transit network. And then the remote endpoint is going to be 10.8.222.2. And again, for my phase 2 encryption, just similar to before, AES, SHA-256, pfS14, 3600 for a lifetime. So now that we have that all determined, first things first, you just go into IPsec and make a plain phase 1. There's nothing fancy about the phase 1. It's just the usual stuff. Set your IKE version to match, and then however you connect to the remote. Give it a description. You set up your authentication, your encryption, so on and so forth. Nothing too fancy there. Once you've got that, save your settings, and then you go here and add a phase 2. Now your phase 2 settings, the first and most important thing to do is you set your mode to routed VTI. Set your local network to a network, then put in your local side of your transit network. So here I'm putting in my 10.8.222.1/30, and the remote is just a single address. It's locked to that because the subnet mask of the interface is determined by your upper number here. And then for your other encryption and auth and all that other stuff, just set it up, however you need to, just so long as both sides match. You shouldn't need to worry about a keep alive or anything down here because it's going to set up gateway monitoring automatically by the time we're done. So that'll take care of keeping the tunnel alive. So after you're done with that, you just save and apply changes. When you do that, it will create the IPsec interface. And if we go to interface assignments, you'll see it here. Right now it's got an IPsec 1000 interface, and I have this already assigned. It will show up for you directly after you create it in this available network ports list. And then from that list, you can pick it and then click add. Then it will come up here and it will get added as an opt interface. So as you can see, the numbering is IPsec 1000, and that's numbered as 1000 because it corresponds to an internal connection ID in StrongSwan. It's like con 1000 there. And that also has to line up with a request ID that we set, and I set that rec ID to be the same number, so 1000 in this case. We had to set them that way because down low in the single digits, StrongSwan will automatically assign rec IDs, and it will just clobber things, and you might find that it was working very inconsistently before we renumbered them this way. So once you've got that picked, click add, And then we'll just have to go up here to interfaces, and then you'll find it here. It might be opt1, it might be opt2, you know, whatever your next available opt interface is. And the only thing you need to do here is enable and set a description. You know, leave these configuration types as none. In fact, I'm about to go add some code to hide these fields when you're on this, because setting them to something else is just going to hurt you. You don't need any of these other options at all. Just leave it all blank. And just hit enable and type in a description, then save and apply. Now you've got your interface. So next thing you need to do, like any firewall, like any IPsec, is just go to Firewall Rules, IPsec interface, make sure you got some rules here. I'm just going to pass everything so you can do that. At this point, we've also got a gateway, so we can go to System and Routing, and it will automatically have created this IPsec VTI interface. Well, see, I called my interface IPsec VTI, so that's the first part of it, and then it puts VTI v4 for IPv4 gateway there. So interface IPsec VTI, and then it's got our gateway and monitor IP automatically filled in, and that was all automatically generated. Easy peasy. And if you notice at this point too, the interface is available for other things. Like if we go to status and traffic graph, you'll see the interface can be picked here, either the assigned version or the raw version. Both goes to the same interface. So we can see like our ping traffic and stuff happening there. If you go to like do a packet capture, you've got it available here as well. You can packet capture on it. So any place like a daemon or whatever could bind to that if you need to, and it should work out for you there. So in general, it's there and it's working, and everything is just like most other interfaces. It's not 100% the same, but everything we've tried so far has worked on it. So all right, so next, looking at just a plain static routing example, this is going to be our simplest, most basic example. You just need to go to just add a static route. So we go to System Routing on the Static Routes tab, and this is just the LAN at the opposite side. So this is the LAN on the remote end, which I should have put in that list of settings I determined back there. So we've got our destination network here is 10.5.0.0/24, and the gateway is our IPsec interface. And then I put a description in, save and apply, and you're done. Then I just need to go over here to diagnostics and routes, and I can see I've got my 10.5 network, and it's routed across the IPsec 1000 interface. And so if we go on the far side here, it's set up very similar. So if we go to system routing and look at the static routes there, you can see it's got a route back to the other side, which is 10.8.0.0/24. And we look at our diagnostics routes, and we should see a route to 10.8. There's our 10.8 route. All right, so these two sites have routes back and forth to each other. We should be able to go to ping here and do 10.5.1. And if we send a ping just like this, it's going to source it from the IPsec interface. And we know that's going to work. That's pretty easy to make work. But if we source it from the LAN, this is the trickier part. This checks our LAN to LAN routing. And you can see here that worked too. It sent a ping to 10.5.0.1 from a source of 10.8.0.1. And so we know that 10.5 and 10.8 are routed to each other now. So very, very simple, and it very easy to get that to work. And but from here on, you could do whatever else you want with it. You could, like I said, you could set up policy routing or any kind of other things you want to try. All right, for a little bit fancier example, you can do a dynamic routing setup, and I've got a couple open here I want to show you. First, you have to install a dynamic routing package that supports the protocol you want. You could do BGP or you could do OSPF. And if you're curious about how to set that up, you can go back to our December 2017 hangout we had on dynamic routing with FRR, and we talked about how to set that up back there. I'll skim through some of it here, but if you need more detail, go back and look at that hangout. If you need to use the Quagga package, it supports OSPF. You could do manual BGP with that, but that's been superseded by the FRR package. So I wouldn't use Quagga if you can help it. We have OpenBGPD, which I'd avoid that if possible. It can do BGP, and it does work, and I've got one I can show you, but it's not ideal. I'd stick to FRR at the moment. Okay, so doing FRR, the first thing is you install the package. Just go to System Package Manager, find it in the available packages list, install it. Then if you go to Services, then FRR Global Zebra, just enable it. You can put in the master password, which is just a random password that FRR uses to talk to its own like status daemons and internally. You can plug in a router ID, which is the LAN IP address of your firewall, is the best one to use for that. And then after you set that, you can save and then go over here to the BGP tab. You put in a local autonomous system number, which if this is just internal to you, you won't have one of these, you just make one up. You can do like 65501 or something like that, and 02 on the other side. Doesn't matter what you use here if it's internal, but generally I think it's the 65,500 range for internal things, or maybe just somewhere around up there. I don't have the exact one off the top of my head. I think I covered that in the previous Hangout. You can plug the router ID in here again. If you don't, it'll pull it from the other tab or the previous settings as well. I like to put it in both places, but you don't have to. And then down here, you put in, at the bottom, you put in the networks you're going to distribute. So this would be like your LAN network on this firewall. Like, see, there's 10.6.00/16. And if you're chaining a bunch of things together, like you've got like, 3 sites, A, B, and C, and, B and C both connect back to A, and you want to reach, C from B, but they want to route through A, you can do things like redistribute your routes, redistribute OSPF routes to BGP neighbors and things like that, and kernel routes. You can kind of redistribute things so that you get all of your routes everywhere. But again, for that kind of stuff, you can refer back to the previous Hangout if you're curious on how to do that. But for now, just put your LAN network in there, save, and then come over here to neighbors, add a neighbor. And I've got this is the IP address, the remote IPsec endpoint of the far side. I've got just gave it a description of the name. I'm not going to use a password or anything. There is the remote AS number, which is like I said, it's just a number I made up for the far side. But that number has to be set on the far side as its own number. Update source, I picked my IPsec interface here. And that's it. You don't have to set anything else. You can just scroll all the way to the bottom and save. And at that point, you should be fine. You go over to the other side and see on the other side here, I've got it set up in OpenBGPD, which is a little bit different. Here, you put in your AS number, you put in the router IP, put in your networks. You have to go over to groups and define a group first, and that's where you put the AS number for the far side, and then in a neighbor entry, you put in the neighbor IP address, pick the group so it has the AS number, and then I set the local update source there just to make sure it goes the right direction. So very similar, but not, as you can see, clearly not identical. Same settings, just in different places. So if we look at our status, now see this side here should have the 10.6 network, and the far side has a 10.7 network. And as you can see here, I've got a BGP route coming in for 10.7, and that's coming through the IPsec interface. And if I go to the far side, I've got a 10.6 network coming in, and that 10.6 network goes to 10.6.106.1. It's a little bit harder to suss all this out in OpenBGPD, but you can also look at the neighbor output and see that it's got a BGP peering to the other guy, and it's up, and you can see everything they're exchanging. So that's all happy. And then you can look at your routing table if you want to be extra sure and confirm that it's all there. So I got my 10.7 route going across IPsec. So same situation here, where they can have, the routes back and forth, and you can ping back and forth and everything. I think if I had another slide here. No, not quite done with this one. Okay, next one here is OSPF, which is very similar. But you just go, like in FRR, you just go to the global settings again and put in your enable, put in your password, put in your router ID, and then go over to OSPF. First thing you have to do is add your interfaces in OSPF, and you just add your IPsec VTI interface here. As you know, just put a description. You can leave everything else blank unless you've got multiples, and then you might have to set metrics. But you just add that just as it is, and then you add like your LAN and other local interfaces here but you want to mark those as passive. And then once you've got all of your interfaces defined, OSPF settings, you just enable it, plug in a router ID, you can put in an area. If you don't have anything else, just put in like all zeros like I've done here, 0.0.0.0. You can leave everything else at the defaults and save, and that's it. The Quagga package I've got over here on the other side, the setup is nearly identical, except some of the things are consolidated in one screen here. Your interface settings are going to be practically identical to FRR, and then your global settings, actually I think they are exactly identical. Your global settings are going to be combined here into one. You've got your master password, router ID, area, and that's it. But if we check our status here, this one I'm looking at holds the 1018 network and the other one holds 1019. So you can see my neighbor is 1019. I've got a full neighboring up to it. And I have a route coming through for 1019. And everything is there. And that's just the OSPF status. If I go back here to all, I should be able to see an O route here in Zebra. Yeah, there's the O route showing that it's going across IPsec 1000. Same over here with our other end in Quagga. Shows it's got a neighbor. We've got a route to 1018 over here over IPsec 1000. And we've got our O route in the Zebra routes showing 1018 there as well. And those are all, again, dynamic routing with OSPF works just fine. You don't, nothing real fancy going on there either, just standard OSPF. And one last example here I've got to show you. This one is BGP again, looks identical to the others, but we have a BGP route coming through for 10.2, and that guy is coming from Tensor. I've got it hooked up to. You can look at my show routes, and this one here is holding the 1014 network. And so we've got a route to our 1014 network here in Tensor coming across IPsec 1. And if I look at my BGP neighbors, you can see here I'm hooked up to 1014.01. It's been up for over a day, and everything is fine and dandy. I'm looking over here. I got my 10.2 route by IPsec 2000 because the Tensor instance is doing a 10.2 network. And everything's as I expected. So that's all well and good. So I've got, you know, I had BGP talking between FRR and OpenBGPD. Got over here, I've got FRR and Quagga talking OSPF to each other. And naturally, FRR to FRR works in either of those situations. I just wanted to show you that it interoperates pretty well. And that's pretty much it for dynamic routing. There's really not that much to it for these simple internal routing examples. You can get a lot fancier with it, but for the time being, really, you know, just internal routing from one side to the other, very straightforward, very simple, and it can handle all that dynamically. And like I said too, as you get more interfaces and more sites, your dynamic routing pays off more because you'll have, you know, things talking to each other across it that will sort of sort their own routing out. You don't have to, like if you had 3 sites talking with IPsec before, you had to have phase 2s at every leg that talked, you know, that had every other leg involved, and it would just, as you add sites, that got to be more and more complicated you had to add phase twos everywhere. You know, you always had to add them and manage them, and it was just a management nightmare. But now you can route everything. You don't have to have all that overhead if you use dynamic routing. If you use static routing, you would still have to maintain all those routes, but you might be able to summarize them a little bit better than you could with IPsec. Because IPsec, if you tried to set up summarize things, you could end up in a trap where, like, if your own LAN was part of the network you were summarizing and you had that shunted into IPsec, you could have some issues with like OpenVPN trying to talk to your LAN or something like that. So yeah, it just all the kernel magic with policy-based IPsec could really throw a wrench in your plans if you were trying to manage things in that way. But now with routing, it all just routes, and it's very natural. It works very well. One last thing I want to talk about is policy routing. You can do policy routing, like if you have an internet provider type connection that works with IPsec, where you're trying to shunt a bunch of traffic off through IPsec or just selectively do it. If it's like, say it's two of your own pfSense firewalls, like one's at a data center, one's at a remote office, and you're trying to route some internet traffic out through the data center, whether you're trying to send it out a different geographical region or whatever, you can do that with OpenVPN all day long, but now you can do that with IPsec. So first thing you'd have to do is set up outbound NAT. So if you go to Firewall and NAT on the outbound tab, you can switch over to hybrid outbound NAT, and then just add a rule that will do NAT on your VTI interface and NAT, whatever your local networks you want, with a translation address of the interface address. And that kind of NAT works okay. I have tested that. That works just fine. Another thing you can do, instead of NATing that way, you can NAT on the other side, where your actual outbound NAT happens, where you go from A to B and then NAT as it leaves B. You can do it that way. That works even better. So you're just routing internally. You don't have to worry about your NAT inside. In either case, if you go to your firewall rules in your LAN tab, you can set up policy routes. Let me just show you what those look like. Just standard policy routing rules. You just have some traffic that you're going to send through your IPsec VTI interface gateway. And nothing terribly special about that. It just goes through the far side. Alrighty, and that's it really. We do have the Fuse service that we have been using here to host these Hangouts. They're sunsetting this particular meeting product, so we're going to have to find something else. So how we get to these meetings is going to change fairly soon. I think maybe next month's Hangout will still be okay, but after that, this will be gone. So we'll have to hook up another type of meeting product. So we'll get the info out on that as it happens. But if you have any other ideas or questions or whatever, just let it rip. So. There's not many people here, but if you do have any questions, feel free to ask. Let me know. If you do have a question, it's going to take you longer to type. Go ahead and just type something short so I know, like sort of raising your hand, so I know there's something coming. I don't want to cut anybody off. Alrighty. It looks like that Comcast outage is just getting worse and worse and worse. Yeah, I think the Comcast outage may have affected people getting the Fuse. I don't know. I managed to get here okay, and a couple of you did, but I know some people are just really having trouble getting anywhere because of it. So hopefully that won't be going on too much longer. And then we'll have, this will of course be in the archive. So we'll have that up fairly soon, next week probably. If you know anybody else that wants to watch it, they can always get it from the archive. All right. Well, I think I'm going to go ahead and call it there. So again, if anybody has any questions, you can post them on the forum or on Reddit about routed IPsec or whatever else, and we'll get back around to them, and we'll see everybody back here next month. Thank you.